Dear ladies and gentlemen, this is part of a research project what was financed by Ukraine and France on comparison of emerging pollutants in two contrasted socioeconomic regions. If you are talking about what's been contrasted and what's the problem linked to that, for example, in European Union, in this presentation and in a lot of publications, what found there is a variety type of trace pollutants that were detected in streams and waters, groundwaters, wastewaters. The legislation, environmental legislation, is developing, but your closer neighbors, Ukraine and other post-Soviet countries, actually for me it was even difficult to find how to call. Is it developing countries like Belarus and Moldova, transitional economy countries? What's going on? So there is a lack of monitoring programs and tools, and there is a huge problem with data application and environmental legislation assessment. So you can see this is a post of water monitoring, so we are using some traditional method of sampling. And unfortunately, no one before analyzed or made monitoring of emerging pollutants no in Russia, no in Ukraine, no in Moldova, no in Belarus. So unfortunately, because it's also the problem that people not understanding this situation. And if you're talking about emerging pollutants, it's mostly pharmaceuticals. This is organic emerging pollutants, mostly anthropogenic origin. And their presence in the environment very relate to economic and socio-economic issues of the region. The first, it's consumption value, also the drug regulation and control, and of course wastewater management and treatment facilities. Pharmaceuticals and man-made substances, so their properties are well known. Among them we have pharmaceuticals with really very contrasted one: hydrophobic, hydrophilic, weak acid, strong acid bases, persistent and not persistent in the environment, bioaccumulating, not bioaccumulated. So those properties mostly known because it's man-made substances. In one of our research, we divide these pharmaceuticals on three major groups, like labil, paracetamol, caffeine, so they're very water soluble, conservative, like carbamazepine, diazepam, so they have very low water solubility and bioaccumulation rate, and there was a group of so-called mixed compounds, among them diclofenac and ketoprofen. It was based on removal efficiency, bioaccumulation, and water solubility rate. Actually, it helped us in further analyze the data with classification. The purpose of pharmaceuticals in the environment. So mostly this is consumption. Growing consumption. So if you are talking growing consumption, for example, you go to doctor in France and they give you the huge list of pharmaceuticals what you need to use, you need to consume, and some of them repeating. Because why? Because they have insurance system, everything connected to the government, and people consume pharmaceuticals. Also antidepressants. And in Ukraine, if you go to the doctor, but actually it's very rare if you go to the doctor. Normally people not go to the doctor because they prefer treat themselves or treat with the help of mother and buying a lot of pharmaceuticals what they are not using, or maybe they are not buying anything because some advice from pharmacy, so they're not going to the doctor. Why? Because there's absence of insurance system, absence of some health care on the governmental level. So concerning the health care on the governmental level, if you can see this data, France, access to the pharmacy. So it's like 2,000 people per shop. And drug use, it's about $300 per person per year. Expenses on healthcare is 3 times higher than in Ukraine. In Ukraine, you can see what the number of shops also less, and the drug use at more than 10 times less than in France, and expenses on healthcare very small. And so in this research, we did like 3 years monitoring of pharmaceuticals in watershed of France and Ukraine in order to estimate the regional pharmaceutical consumption using water monitoring data and to make cross-country comparison. Maybe it's a little bit strange application for the water monitoring data, but it's one of the way to show how we can use the water monitoring data for different purposes. And the first region, it was Ukrainian region in Kharkiv. Kharkiv, it's a big city, it's 3 million of population, and with very contrasted continental climate and a very low precipitation rate. And we have 2 wastewater treatment facilities based on mechanical and biological treatment. They are treating about 1 million cubic meter of wastewaters per day. They are operating, and they are discharging in 2 rivers just after the city area. So we monitored the upstream city site, city area, and downstream wastewater treatment plant. But actually, we also took the transboundary. It's transboundary river with Russia, but I'm not presenting results here. But we found that Russia discharged some pharmaceuticals on our territory also. And in France, we study Bordeaux region. This is 400,000 population with also 2 wastewater treatment plants, oceanic climate. And we also using the same approach for 2 regions, the same monitoring, sampling, and data treatment. So concerning the sampling, here we use the only passive sampling technique. So why? Because we need to transport all samples in France from Ukraine, because it's not possible to make sampling analysis in Ukraine. And also it was one of the major tasks to develop the chemical protocol on POSIS polar integrative samples. So we installed it for 21 days in rivers in different conditions. We took 3 major hydrological periods: low flow, high flow, and cold, extremely cold winter conditions. After samples were taken from the river, and pharmaceuticals was extracted using mixture of methanol dichloromethane with different proportions, proceeded with liquid chromatography mass spectrometry tandem with positive and negative electrospray. And it was interesting for diclofenac, the both minus and plus was working good. Data quality control, we using the field and laboratorial blanks, spike and recovery rates, gravimetric control for all standards, and detection limits. Among all pharmaceuticals, we took such types like bronchodilators, anti-inflammatory drugs, lipid regulators, stimulants, psychiatric drugs, analgesics. The selection was based on application of analytical techniques and also on the presence of pharmaceuticals on the market. It was interesting what among various groups, 3 pharmaceuticals were not found in Ukraine. So possibly it's not widely consumed or very small amount, consumed in very small amount. What the first data show us, it was very interesting to see what in 2 regions with contrasted conditions, we found what we have in Ukraine. The first group, it's carbamazepine, diclofenac, caffeine, ketoprofen. And in France it was almost the same, but in different proportions. So this is widely consumed pharmaceuticals in possibly in 2 regions. And because its value in nanogram per gram of other sorbents, what integrated in the positive samples. And in concentration in rivers in the upstream side. So here presented the data for the May warm period and December cold period. We found what upstream sites, we have a domination of non-prescribed pharmaceuticals. In upstream of the urban area and wastewater discharge, the caffeine, diclofenac, ketoprofen, and paracetamol are dominating in both regions. And what it can give us? So if pharmaceuticals present before the urban area, before the wastewater discharge, so it means there is a source of waste particles, of the substances in the environment. And downstream sites after wastewater treatment plants, we found that there is increasing amount in the occurrence of prescribed pharmaceuticals, like carbamazepine, diazepam, and also in both regions. But you can see the concentration is really very different. For example, carbamazepine was detected up to 300 nanogram per liter in Ukraine. It's really very high concentration. But it's interesting, also carbamazepine mostly used here in European Union and other countries like anti-epileptic drugs. But in Ukraine it have different application. It's using for anti-alcohol dependency. So people who consume a lot of alcohol, in order to back in normal conditions, they using carbamazepine. Yes, and this is strange application, but yes, it's Ukraine. Yes, and diclofenac, it's also very traditional pharmaceuticals in Ukraine. It's our panacea, so we are buying it in different. It's produced in Ukraine, so it's consumed in very high amount because it's not prescribed. People just treating everything with diclofenac. Yes. And even for like veterinary drugs, like human drugs, so it's very cheap and acceptable on the market. So carbamazepine, very high amount. You can see the concentration for Ukrainian river, like for diclofenac and carbamazepine is really very high compared to French rivers. And some pharmaceuticals, actually it was ketoprofen who has the highest seasonality. Maybe it's also linked to the impact of photosynthesis on these pharmaceuticals, what is degraded under the influence of radiation. But it's also have very wide application like veterinary drugs, even in Ukraine. So there should be some more research on seasonality of those substances. And it's also, you can see previously I showed what we have less access to pharmacy, we consume less pharmaceuticals, but our river more contaminated, much more contaminated than previously reported river in European Union, in terms of concentration, even than French river. Why this happens? Because we are discharge huge wastewater treatment plant, discharge all wastewaters in one river. So during the Soviet Union we had this practice, what we are building only one wastewater treatment plant, not for each district, but one big for the city because it's cheaper. And now everything discharged in the river, and the dilution like 7 parts of wastewater to 1 part of river. So it's mean what the, I don't know who diluting whom, but 7 parts of wastewaters to 1 part of the river. So it's mostly wastewaters. And of course, we are using mechanical and biological treatment, but still we are not using advanced treatment. And of course, some pharmaceuticals are able, like carbamazepine, just coming in the river and going in the environment. How also we applied this data? So we built the mathematical model in order to estimate the regional medicament consumption rate for caffeine, carbamazepine, and diclofenac. We found that caffeine mostly consumed in France, carbamazepine have higher amount consumption in France. All pharmaceuticals have higher amount of the consumption in France than in Ukraine. And using this model, we take into account the water flow rate in river, dilution processes, concentration of compounds upstream, downstream sites, and data on excretion rate and efficiency of wastewater treatment plants. After we compare with available data, unfortunately for Ukraine it was not available any data about the consumption of pharmaceuticals, but it was interesting But for carbamazepine, the data close, really very close to the consumption rate. Of course, there is a difference in years, but still, if we update such models, we can approximately estimate the consumption rates of pharmaceuticals, and not only pharmaceuticals, but maybe some illicit drugs and different compounds. And in this approach, we can use the data not only for the toxicity and environmental impact assessment, but for criminals and for socioeconomic research. Like conclusions to our research, I would like to tell what consumption patterns, wastewater treatment efficiency and management, together with hydrological and hydrochemical conditions, influence the accumulation of pharmaceuticals in the environment. And with water monitoring data can be applied not only for toxicity, for the environmental impact assessment, but for the very wide range of the application. And pharmaceuticals properties in distribution in one of the research later we used for identification of treated and untreated wastewater inputs, because they work very good like markers, potential markers of different type of wastewaters, treated, not treated, mixed with industrial and pure municipal, even for runoff. Because we know their properties, we can predict their presence in the environment. At present time, we are doing some experiments on treatment of emerging pollutants on constructed wetlands. Today we had several presentations about the conventional treatment using the conventional wastewater treatment plants, but the problem, like it's expensive to install such facilities. And also, okay, you take off pharmaceuticals from water, but you still have it in sludge. After you take off from sludge, what to do after? This is real. If you once put pharmaceuticals in the environment, it's difficult to take it off back. And constructed wetlands now showing the efficient way for the removal, because it's also very good for hydrophilic substances like pharmaceuticals. And we are doing now experiment with passive samples on estimate the removal efficiency of constructed wetlands for hospitals, because in Ukraine we have a lot of, in our city we have 40 constructed wetlands, because no money for conventional treatment facilities, and most of the hospitals, prisons, they're located out of the city, so they cannot discharge wastewaters in the municipal treatment plant. So, and government doesn't support the building of conventional treatment plant, but for the constructed wetlands it's very cheap. So they're operating, but have no any idea how the constructed wetlands work in contrasted climate, because it's winter, -20, -40, and it's summer, +40, plus 40 we have. So we have very like 80-degree of difference. And with contracted wetlands, they're operating during the whole year. And unfortunately, we don't know how they're treating, and in Ukraine, we don't have analytical facilities to analyze it. And we are searching some cooperation who will be interested in such project and who can be one of the co-authors of the first publication on Ukraine and on pharmaceuticals. So thank you very much for the invitation here and for your attention. Thank you.